Algebra 2, coming up for assessment number 3, data analysis. So real quick, just some reminders, things you know. Um, you got to have a TI Inspire. You got to know the commands. Okay, this is heavy on calculator page, data and statistics page, spreadsheet page. How to find common one variable statistics. Go through the menu option and read which those elements are. How to create a box plot. Okay, if you add an element to a box plot, resizing the window, I think we did that. How to identify outliers. Pretty easy once you have a box plot. How to create a histogram. Okay, reading information from a histogram. Okay, so this is something that is going to require your intuition. The calculator is not going to do this because histogram data has been grouped, and things like median and mean, this comes from raw data. So you're going to have to use some intuition for some of this. Some technical thing, changing the bin size, the width of a histogram. Coefficient of correlation, that comes from linear regression calculations. How to calculate that, what does that mean? There'll be some questions about this correlation. What does it mean? What does interpreting what the correlation means? How to graph and calculate the line of best fit. The independent versus the dependent variable. We talked a little bit about that. That if you're measuring the height of a student as time goes by, time is the variable that's really just moving on its own. The height is what I'm really interested in. I'm measuring. So independent variable is time. Dependent variable is height. If I was talking about the cross country team, and I'm talking about the time of your race, that's something that I'm measuring. So I might say like how well you do in a race based on time of day. Time of day is something that's just evolving and happening, but I'm really wanting to measure and quantify your race time. So that could change there. Answering questions in context. So if you've got an application problem or a word problem, your answer should have words. Your numbers should relate to that application. Looking at a variable, or excuse me, looking at data that comes in a two variable data. So you've got chart data that has two variables reading information from that chart. So this is a lot that we did in this short 3-day unit, but now let's take a look and see some sample problems. So here we have an application problem that's set up. It's going to ask us several things about this data set, and it's also going to come into a line of best fit. So let's take a look at this one real quick. And let's just go ahead and enter the data. I know this data is going to have to be there, so let's just go ahead and enter on our calculator. So that is, I'm going to create a new list and spreadsheet. So it looks like the variables that I have here, I've got the year. And then it looks like I've got volcano eruptions, in cubic centimeters of ash. So you can call it, volcano eruption. You can call it ash, whatever. We'll just call this ash. And so now I just want to type in the data. One of the most important things at this point is you've got to be 100% accurate. So 1957, 1960, 1961, 62, 63, 1962, 1963, and then 68, 69, 1969, and 71, 92, 1971, 1992, 95, 96, 95, 96. So those are the 11 years. Count them: 2, 4, 6, 8, 10, 11. So it's 1957, 1960, 61, 62, 63, 68, 69, 71, 92, 95, and 96. Okay, all those are there. And then the eruption of ash. So 0.074, 0.095, 0.095, 0.095, 0.096, 0.115, 0.115, 0.142, 0.152, 0.152, and 0.160. So make sure I've got all of those correct. Like I said, if you get it wrong, then your numbers are just going to be wrong. It's going to be very hard for me to grade this. 74, 95, 95, 95, 96, and then 115, 115, 142, 152, 152, and 160. And that is it. Okay, so now I've got the data. Now, what are they asking me in this question? What's the average of eruptions? So when they're asking for the average of the eruptions, they're asking me what is the average of this amount of data here. So I will go over to my calculator. And so at this point, I'll just create a new control doc, create a new calculator, and let's just do menu, statistics, stat calculation, one variable statistics, one list of data, and I'm interested in the ash data. Okay, so that comes back and gives me information about this. Remember that the average is going to be X bar. So 0.117364. So 0.117364. That's the number. But what is the unit? It's cubic centimeters of ash. So cubic centimeters of ash. There's my number and my unit. What is the median amount of eruptions? Okay, that's straight from reading that statistics page. So if I go back to my calculator, the median is 0.115. So the median is 0.115, again, cubic centimeters of ash. What is the total volume? So if I go back, total volume, I'm looking for right there where it says the sum of all values, sigma x, 1.291. So 1.291 cubic centimeters of ash. What is the standard deviation for this data set? Standard deviation is SX 0.029449. 0.029449. What is the value of R, and what does it tell us relative to this data set? Okay, the minute I move into talking about R, I'm talking about correlation. So correlation involves two data sets, okay? So which of these data sets is my independent variable? Okay, so which of these things is just happening and I'm not doing anything to it, and which of these things am I measuring because I'm interested in studying it? Well, the years roll by without you interested in studying them. So the years, that's going to be my independent variable. What I'm really interested in measuring and studying and quantifying is this cubic centimeter of ash. So the way I'm going to do the correlation in this data set, go to your calculator and let's just say menu. And we can do a couple of things here. Statistics, stat calculations, linear regression, and let me back up. Make sure I did this right. Menu, statistics, stat calculations, linear regression, make sure it's mx plus b, number 3. So what is my x variable, my independent variable? That is the year. What is my y variable? That's the amount of ash. And so if I do that, it comes up with an equation for me, y equal mx plus b. So I get y equal anyway, that's the equation of the line. I'll get that. That's the next part. But the first part was asking for the correlation coefficient. So you see R is 0.934921. So 0.934921. 0.934921. That's my correlation coefficient. What does it tell us? It tells us that this is a very strong positive correlation between the year and the eruption volume. Okay, I know it looks like a lot of words. This is just coming straight out of the word problem. What am I correlating? I'm correlating the year versus the eruption volume. Okay, what is my equation line of best fit? Okay, so the equation line of best fit is y equal mx plus b. So y is 0.001856. Y equal 0.001856 x. So y equal mx plus b, and b is going to be minus 3.54214. 3.54214. 0.214. People ask, do I need to round this off? No, it doesn't cost you any money to write down what the calculator found. So just write everything is, carry all the places, and that should be good. What does the slope of the line tell me in the context of this problem? So what is the slope of this line? It's 0.001856. So if you look at it, if I were to graph this, and I could certainly do that, I could create a new page, control doc, and I could say data and statistics. I could look at the year. And sorry about this. I'm going to. So if I graph this, so I pause there for a moment, but what do I do? I want to graph this so I can see that line of best fit. So I'm graphing the year versus the ASH. There's my data. And then I could do menu, and I can say analyze regression and show mx plus b. And I see that line that we just came up with a moment ago. So this is telling me that, okay, it looks pretty good to have the linear model here. So if I go back to it, what does the slope of the line tell me is what I'm trying to answer here. So if I look at this, what does the slope of that line tell me? Well, my horizontal axis is year, vertical is ASH. So the slope tells me the change in ASH. Remember, slope is change in Y over change in X. Change in ASH versus change in year. So what this tells me is that I can expect there's a 0.01856 cubic kilometer of ash increase per year. So on average, that's about how much I can expect the increase in the ash eruption to change per year. And I'm just reading that from the slope of that line and putting it in context of the problem. What is the expected ash volume in the year 2018? So that means Y equal 0.00186 times 2018 minus 3.5424. So I'll just put this in my calculator. So 0.001856. So let's just create a new calculator. So 0.001856 times the year 20, what did I say, 18? 2018 minus 3.5, that number was 3.5424, 4214. So 3.54214, 3.54214 equal. So 0.203268. So 0.203, what was that again? 0.203268. 0.203268, that is expected ash volume. So that is the ash volume in 2018. When do I expect the ash volume to exceed 0.207? So when do I get 0.207 as my answer? So what year? I'm solving for X. Okay. So solve that for X, and all you're going to end up with is 0.207 plus 3.54214. All of that divided by 0.001856, and that gives me X. And let me make a little bit of a correction here. So I put this in my calculator, 0.207. So 0.207 plus 3.54214, is that right? Okay. All of that gets divided by 0.001856. Is that right? 0.001856. So 0.001856 equal 2020.01. So I get x equal 20.01. What year is that? So that tells me that's the year 2020. So we expect the volume to exceed 0.207 in the year 2020. Okay. So if that had been like 2020.8, that's still the year 2020. Okay, it happens in the year 2020. Okay, well, let's move on. So there were a lot of little pieces to that one problem. The next one, you know, this review, this was the test a couple years ago, and this is something the kids hadn't seen, but I was just trying to see, can they intuition their way through this? Besides the coefficient of correlation R, statisticians will square the coefficient of correlation and use that measure. That's called the coefficient of determination, R squared. Which data set would have the weakest linear correlation? Okay, so weakest linear correlation. So remember, correlation is a number between -1 and 1. Okay, when you get to -1, that's a strong negative, and 1 is a strong positive. Okay, so the weakest correlation means the number that is furthest from -1 or 1. 0 is the weakest number you can get for correlation. So I'm basically saying which of these numbers is furthest away from 1 or -1. Okay, so this is 0.987. If R squared is equal to 0.980, then R is equal to the square root of 0.980. So you've got your calculator. What is the square root of 0.980? That's 0.989949. So R equal 0.989. What did I have? 0.989949. 0.989949. And then here I've got R is -0.99. So if I look at these R values, which of these numbers is the furthest away from 1 or -1? And the answer has to be A. That's the number that's furthest away from 1. Okay, you can subtract or 1 or -1. Okay, so this is the weakest correlation in part A. Now the next one, I give you several visualizations. The age of a president at the time of their inauguration. So I see a histogram, I see a dot plot, and I see a box plot. What I don't have is the data. I've got visualizations. So what is the median age of the president at the time of inauguration? So the median, if I look at all this data, I got a couple of choices. I can count up all the number of presidents. There are 45 of them. So there are 45 presidents. There should be 45 dots there. So that tells me that I've got 22. So it divides up like this. So the 23rd data element should be my median. So I could count up dots until I get to 23. Or I could just look at this box plot, this middle line right here. That is the median. So if you look at it, this is 52 and that's 54. So the median looks like to be 55. Okay. And you can, like I said, you can count up dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 falls on 55. Okay, so 55 is the median. What is the difference between the oldest and the youngest president? So it looks like my oldest president is right here at 70. My youngest is at 42. So this is 70 minus 42. So that is, what, 28? So this is 55 years, 28 years. What percentage of presidents were between 51 and 55 at the time of their inauguration? Okay, anytime I see that, I'm hoping that corresponds to a box plot. So 51, here, this is 51 right here. And then 55 is right here. So that tells me that this is a quarter of the data. So, you know, this is 1/4 over here on the whisker, this part of the block. So this is 25% of the presidents. how many presidents were older than 68, okay? So if I look at 68, which is right here, it looks like I've got 2 presidents that are older than 68. And you could also get this off of the histogram. Well, let's see. Yeah, so the histogram right here, this value corresponds to 2, okay? And if I look at the youngest 25% of my presidents, the youngest 25% of my presidents, that deals with this range right here. So that looks like that goes from 42 to 51. So that is from 42 to 51, okay? So really, there's no calculation on the calculator on this one. You're reading data from a chart. Now, another example here. The second worst collapse in Atlanta in 2017 was the bridge over I-85. The worst collapse was the Atlanta Falcons in Super Bowl LI. For that season, the offensive scoring of the team were these totals. Okay, so they're going to ask me something about that, so I need to enter that in the calculator. So I'll just go to my calculator, and I can just create a new one. So let's just say Control. We have list and spreadsheet, and I'm going to put the scores of the Falcons in here. And so the scores of the Falcons are 24, 35, 45, 48, 23, 24, 30, 33, 43, 15, 38, 28, so 38, 28, 42, 41, 33, 38, 36, 44, and 28. Okay. So what are they asking me? They're asking me for some data about this, so I can go and just create a new calculator page. A couple ways I can do this. I can say menu, statistics, stat calculations, one variable statistics, one list, and I'm looking for the Falcon data. And so what are they asking me for? So they're asking me for the minimum. So it looks like the minimum is 15. So the minimum is 15, and the quartile for Q1 is 28. The median is 35. The quartile Q3 is 42. And the max value was 48. Now, the other way you could do this on the calculator, you could just say, let's create, instead of that, we could create a data and statistics. And I could say, let's look at the Falcons data. And what I want to do is to say, let's create a box plot. So menu, plot type, box plot. And here I could just scroll my mouse and see that the minimum of the data was 15, Q1 is 28, median 35, Q3 is 42, and the maximum is 48. So a couple ways of getting that data. And then asking questions. The top 25% scoring games, that would mean that my score was between this boundary right here at the box at Q3 and the tail end of the whisker to the right. So if I look at my mouse, the top 25% of the scores are going to be between 42 and 48, okay? If you're looking at the chart we had here, so that's between Q3 and the maximum, 42 and 48. The top 25% of my scores are between 42 and 48. Another problem. You've been told by one of your parents that the scatter plot below and the coefficient of correlation indicate this data set is not modeled well by a linear line of best fit. Your other parents suggest you put your cell phone away and think about breaking the data into 2 data sets. You decide to take, instead of you parents, it'd be your parents' advice on both accounts. Can you see a way to model this data set linearly if you considered it as 2 separate data sets? Draw your modeled lines of best fit and discuss would one part of the model have a stronger correlation than the other, What are your best guesses for the coefficient? Okay, so this was a tough problem. I threw this one at the class a couple years ago, but I think they can handle it. I think you could as well. Breaking this in two data sets, you can see, it looks like, let me get rid of that. It looks like if I did a line of best fit sort of right here, okay, that looks pretty good for that data set. And if I did another line of best fit for this data set, and let me do the other, and let's just go back. So it looks something like this, okay? And again, not exact, but something like this looks like it would be a good model for a data set. This green one looks a little bit off, but again, I'm not looking for exact. I'm looking, can you look at this and give me some intuition about the data set? So that looks like that would be better than having one line that goes through the data set. So does one have a stronger correlation? You can look at this and tell that right here, this is stronger correlation right here. You can just tell by looking that the line looks like it models the data better than what you see over here. On this side of the data set, this is a weaker correlation. And then I ask, what are your guesses for the coefficient of correlation? Okay, so the coefficient of correlation, if you look at this first side of the data set, so if I'm looking at the first side of that data set, it appears that that's going to have, that line would have a negative slope, so that's close to -1. So I'm going to say my R, I'm just going to guess, and there's no accuracy here, maybe that R is -0.90, okay? So it's a negative number. That's really what I'm looking. It's a negative number, and it's between 0.5 and 0.9, okay? So it's pretty good. Now, whatever I guessed here, this number over here is going to have to be a positive number, and if this is 0.9, this is weaker. So maybe you call that 0.80, okay? Like I said, the numbers don't matter here. What I'm looking for is you got a negative number on the left side of the data set, you got a positive number on the right side, and this shows stronger on the left side, okay? And that should be it for the oh no, there's one more question talking about cars. So I'm reading data from a two-column chart. So this shows survey of car owners. The owners were asked if they received a ticket last year and the color of their car. What proportion of those surveyed were red car owners who received a ticket? So red car owners who got a ticket. So red car owners who got a ticket is right here. There's my total. So that proportion would be 19 divided by 659. Or if you wanted to put that in your calculator, that's 19 divided by 659 and 0.028832. So that's the proportion of owners who received a ticket. Of those who received the ticket, okay? So if I only look at people that got a ticket, so that's people right here, what percentage of those did not own a red car? So did they not own a red car? That means 43 over 62. That's the percentage, that's the proportion that did not own a red car. So 43, and I get 0.693548. What did they ask me? They asked me for percentage. This is 69.3548%. Okay, that's the percentage of people that, if they got a ticket, they did not own a red car. If a red car owner is selected at random, okay, red car owners, okay, here are my red car owners. If a red car owner is selected at random, what's the probability that he or she has received a ticket? So if they got a ticket, that's going to be 19 out of 151. Okay, so 19 divided by 151 is 0.125828. Is that right? 125828. Yep, that's it. If a non-red car owner is selected at random, what's the probability that he or she received a ticket? Non-red car owner. I'm looking at this line right here. If I pick somebody out of that pool, what's the probability that they received a ticket? That would be 43 divided by 508. So 43 is 0.084646. Okay, so that's the probability for that. And one question, a couple more. If the results of this survey were extended to a town of 10,000 people, how many people would report receiving no tickets? Okay, so if I look at how do I find the people that got no tickets? Okay, so if you look at the people that got no tickets, I've got 597 out of 659. Those are the people that got no tickets. Okay, so 597 over 659. So 597 over 659, that's the proportion of people that got no tickets. Well, if I took that and I extended it to a town of 10,000 people, what would I get? So let's just see, 597 divided by 659 times 10,000 is, and let me go back and get a decimal approximation for this, 9059.18. And so here I just say it's about 9059 people. People, we don't have decimals, okay? So you got to round it to something. If a person were selected at random, what would be the probability that that person drove a red car or received a speeding ticket? Okay, so let's go back up here. The probability of someone driving a red car or getting a speeding ticket. So this is where I get the information about speeding ticket. This is where I get the information about the red cars, okay? So if you look at it, what is going on here? So if you look at it and say, okay, it looks like I've got an overlap here of the number 19. So if you look at it, you've got individually, it would be this element, and this element, okay? So I could add all of those up. Those would be all the individual things that could be, I got a red car or I got a speeding ticket. So all of that divided by my total population. So a couple ways of doing this is going to be 19. So what is that? Let me just do those numbers. So that's going to be 19 plus 132 plus 43, all of that divided by 659. And so on my calculator, so it's going to be 19 plus 132 plus 43, all of that divided by 659, and 0.294385. So 0.249385, is that right? Okay. Now, the other way of doing this is you could use the totals, okay? So you could say, you know, it may be more confusing to do that, but okay, speeding ticket. Here are all the people that got the speeding ticket. Here are all the people that got the red cars, okay? But if I use those two numbers, you need to make sure that you understand you have counted this number. You've counted this number 19 twice, okay? You've counted it in the row and the column. So another way of doing this, and you could just check your answer, 151 plus 62 minus 19. I can't count 19 twice, I only count it once, over 659. So let's just try that in our calculator. So 151 plus 62 minus 19, and all of that divided by 659, and it should get the same number, 294,385. Okay. And that should be it for this question. And there we are. That's it for the review.